Hello everyone. Welcome to Geeks for Geeks Python channel and welcome to this live session. So let me just check the audio once and see if it's working fine. Everything is fine. See if it's working. Yes. So the audio seems to be working fine. Video is also fine. We are good to go. Okay. So the topic for today's discussion is distribution of Python code. Okay, so in the last few sessions, we have created command line apps. We have understood command arguments. We have tested some APIs during the course of understanding command line arguments and command line apps. We have understood decorators, wrappers, scrolling plots, and stuff like that. Okay, so in past in last 5-6 sessions uh, we have dived into a lot of programming and coding and creating application kind of stuff, right? And different basics of Python, right? The different concepts of Python we have understood. So we have coded a lot, right? We have understood concepts. But now today's discussion topic is that I have this code, but uh, how do I distribute this code? Okay, so let's say you have some file. Okay, so you have, let's say you have written add.py. Okay, now to execute this, so this is a Python file. Okay. Okay, so this is a Python file. Now to execute this file in your terminal or command prompt, whatever you are using, you would give command py add.py, right? To execute this file, right? So this works good when you are developing, uh, when you are in development stage. Okay, so you just want to test it, so you have to you can execute this command py add.py and you get the output, right? So you can again execute the same command and you can see the output, right? But in real life scenarios, your project is a lot more complicated than just having a single file, right? You will have multiple files. So your project will have multiple files, okay? And thus, these multiple files will have, let's say, file 1, file 2, file 3, okay? So all these files would interact with each other in some way or the other, okay? So this, let's say this file 2 would use some function of file 3, or file 1 would use some function of file 2, then file 3 will use some function of file 1. So there is some dependency, right, in between these multiple files. So you have to organize your code and distribute it, right, for other users to use it. Every time users cannot do Python and then run, I mean, go into terminal and then give the command Python, then run this file, right? So your real life scenarios, your real life projects are distributed as modules, as packages, okay? So we have packages. You would have used pip install commands like these, right? Pip install and then the library name, right? So whatever this install, uh, I mean, this pip use is installing this package, right? Whatever you give as a package over here, let's say Numpy or pandas, whatever. Okay, so this is a package. Okay, so we create a project structure in such a way that all your code is all your files and modules and packages, they are well segmented, and then we create a structure, we add some files to it, then we build those files, and after building those files you get uh, an output as .whl. Okay, so this is one .whl file which is generated. Okay, so you bind everything, you create a project structure, and then you build. Okay, and after the build you get .whl file. Okay, now this whl file can be installed using pip. Installed using pip. Okay, so what we are going to see over here is, let's give you an example of these wheel files. So .whl files, .whl file, Python. So I just want to show you the repository where all these files are hosted. Uh, yes, so uh, this is the website where you can see that this is a library. Okay, so let's search for NumPy. Uh, yes, so here we have NumPy. Yes, so now if you see for NumPy, these are the files. Okay, these are the, if you see the extension of these files, it's .whl, right? It is .whl. If you see this extension, this is .whl files, right? So these files you can download, okay, for NumPy, and for uh, according to your architecture and everything. This is for Windows, so you can just download whichever file is applicable for your system architecture, and then you can compile it using pip. Okay, so that is one method, is to use directly pip. Okay, for that you need to host your package with pip. Okay, so we won't be using that, but we can create a .whl file which can be used with pip to install your package or to install your code into some other system. Okay, so this is what we are going to create. We will create a simple project structure where we will have some code. We will create the project structure, and then we will build the project. So that build will give the access to these .whl files, and then these .whl files will test it in a virtual environment to see if my code is working or not. Okay, so instead of running this Python py add.py, we can directly call those functions from the command line. Okay, so we won't need to, we will not need to call Python again and again and again. Okay, so let's say, for example, if my Python file contains two functions, let's say add, and let's say subtract. Okay, so if I install, if I create the .whl file and then I install it using pip, then in my virtual environment I can just directly call add in my command line to execute whatever is written inside the add function. Okay, I can just directly call subtract, okay, to on my command line to execute whatever is written inside the subtract function. Okay, so this is basically you are packaging your Python code as a CLI application, okay, or as a library, okay, in form of wheel file. So you are packaging you are packaging Python code as a CLI application. Okay, so this is our objective. Once you see the whole tutorial, like the code will be very basic, because I don't want, because this is not an this session is not about teaching you how to code Python, but this is about how to distribute it. Okay, so we will be creating very simple basic functions, and what we want is basically we want to see the distribution functionality. Okay. Okay, so for that we need some project structure and some files. Okay, so I will discuss the project structure now. Okay, so let's say I am creating a file, Python file, .py file, and inside that I have two functions. Okay, function 1 and function 2. Okay, and this is, I want to call these functions from the command line. Okay, using the .wheel file. Okay, because you cannot directly distribute the code which is written in your Python file, right, for anyone to use. If you want to make if you want other developers to make use of your to make use of what you have written inside these functions, you need to distribute in some manner, right? So that's what we are going to discuss. So let's say we have the top root directory, which is, let's say, my root, my repo. Okay, so this is the top level, this is just a folder. Okay, but this is my top level directory. Okay, and inside this I will have my packages. So let's say this is also a folder. So this is a subdirectory inside my top level directory. Okay, so now inside this I will have my .py file. Okay, and in the top level directory where my package is there residing, I will have three more files, uh, which is py.toml file, which is py. I am naming it as py project. So .toml file, and then setup.cfg, and then there is one more which is setup.py. So this setup.cfg is to define your configurations. Okay, define configurations. Configurations can be like the name of the package, author name, author email, maintainers contact details, stuff like that. Additional libraries which you might use, which you are using in your package, right, in your code. So all these all these properties are defined inside setup.cfg. Setup.py just reads this, is used to read the setup.cfg file. Okay, so these two files are useful. One defines the configuration, and the other reads that setup.cfg. So setup.cfg, inside .cfg we define configuration, inside .py we read the setup.cfg. This pyproject.toml is it contains build system requirements for Python projects. Okay, so it contains build system requirements. So if you want to understand what are these build system requirements, uh, you can just Google about setup tools, and you can Google about yeah. So setup tools you can Google about. Okay, and you can also Google about, there are one or two different libraries, okay, which you can also Google. Okay, so if you want to understand about what is these build system requirements, okay, then you can read more about setup tools. Okay, Okay, you can also read about poetry. Okay, and like these are different keywords which you would need to understand what are these build system requirements. But majorly, if you just read about setup tools, it will be good enough. Okay, so we understood the architecture of our project. So we have like a the top level directory. Inside that we have the packages directory. Okay, now what is this package directory? It's just a folder, and it's a folder inside which you have your file. Okay, now there can be multiple packages inside your top level directory, like I have only one, which is my package. You can have multiple, my package 1, my package 2, my package 3. That is basically a way in which you build, uh, in which you combine all the files, and that is basically about your project structure. Okay, so it is debatable topic. You can have it any way you want it. You can either have only one package in which you can have multiple files. You can have different packages, and you can have different kind of files. Okay, so it all depends on what suits your requirement. Okay, but for the example that we'll be doing, we will be having only one package, that is one subdirectory inside the top level directory, and inside that we will have a file where the code is written. Okay, okay, and we have these three files. One is setup.cfg, where we define the configuration properties. Then one is setup.py, where we read the setup dot where we read whatever is defined as a property in setup.cfg. And there is one .toml, pyproject.toml, which contains build system requirements. Okay. Okay, so we will jump into, so first what we need is we need a folder, top level folder, which is my repo. Okay, so let's go and create that folder. So I'm creating a new folder and I'm naming it as my hyphen repo. Okay, so this is my top level directory. Okay, inside this I will go, and what I'll do is I'll create a folder called my package, because if you see, I have my repo, and inside that I have a directory or package called as my package. Okay, so let's go and do that. Inside my repo, I go and I create a new folder which is my package, my package. I'm naming it as my package. You can just name it anything you want. Okay, it's just a folder inside which you want your code to reside. Okay, now if you see the project structure, inside my package I have a .py file where both the functions are written. Okay, function 1 and function 2. So let's go and create a .py file where we want to execute our logic. Okay, so I'll not create something which is very difficult. So I'm just as we discussed, we will create two functions. So first function I'm naming it as my function. Okay, and it can print uh, it can print hello from my function. Okay, hello from my function. Okay, so let's say this is the first function which I have defined. Okay, I want two functions, so let's because it will be good if we test two functions. So I want two functions, so second one I'm defining it as another function. Okay, I hope it's visible. If it's not visible, I'll just zoom in. So another function, and inside this I'll just print hello from another function. Okay, hello from another function. Okay, and okay, let's add one more functionality where because I will be calling my function and another function from the command line. Okay, so just to show that you can also call you can also call a different third function inside these functions. Okay, so that's why I'm implementing this def call function. Okay, just to show that you can also call some third function inside these functions. Okay, it will get clear once we execute it. And here I'm just creating a dictionary which is let's say it contains first name. So my first name, I'm just giving it as a string, Utkarsh, okay, and comma, the second key I want is last underscore name, and this key I give it as XYZ, okay. So this is another function, this is a third function which I'll execute inside my function, okay. So just to show that you can execute different functions inside these functions which you will be going to execute from the command line, okay. So I'll just print, uh, okay, I have to assign it some variable. So I will say, I'll assign it a variable name, and I'll just print the name, okay. So this is what my function does. I'll also import time, and let's do it like this. So I will give a while loop inside this function, okay, and I'll just call, so I'll move this print statement from here so that it only executes once. And now inside while loop, I'll just call this function, okay. So I'm just calling this call function, okay. So it will create a dictionary name and print that dictionary, okay. And after each print, I will just give time.sleep. So I want to wait for some time, and then it should again print the same dictionary, okay. Okay, so yeah, this looks good. So this is just to show you that we will be executing only my function and another function from as a command line option, okay. But just to show you that you can also call some other defined functions in the script into these functions, and those will also get executed, okay, when you execute my function in another function. So just to show that, I have just created this third one, which is call function, okay. And yeah, so this looks good. Let's just save it. And by so where I should save, if you see the project structure, it should be inside my package, right? So I'll go save as, and I will locate my folder, my repo. I gave it as my repo, my package, and inside this I will give this name as my module.py, okay. I'm naming it as my module.py. So it is saved now. Let's just check whether it got saved or not. Inside my repo, my package, I have my module, right? Okay, let's go back to the root. Okay, we are inside the root. Okay, so so this part is done. So this part is done. Now I need to define setup.cfg and setup.py. Okay, so I will open notepad and I'll create the contents of setup.py, okay. So inside, okay, so setup.py I don't need in a notepad. Setup.py I can create from here. I am creating a file, python empty module, okay, open. Okay, now inside this setup.py I have just from setup tools import setup, okay. And the next thing is I just called this setup function. So what this does is this will basically read the content of setup.cfg, okay. So I just need this much in my setup.py. So I'll just go save it, save module2 as, and I'm already inside my repo, my package. So I don't want this inside my module. I mean, I don't want this inside my package. So I'll go one folder up. I want it here. Okay. So I will name it as setup.py. Okay. Because I want it in the top level directory, inside the top level directory. I don't want inside the sub directory, which is my package. Okay. So setup.py, I'm saving it here. Okay. Okay, this is also done. Now, okay, so setup.py is done. Uh, yeah, setup.py is done. My package is done. Now let's go and define setup.cfg. So for that, I'll open the notepad. Okay, so here we need to define the properties. Okay, so I will create, so just follow metadata. Okay, and it's defined like a list. So this is basically like metadata, like what is the name for your package. So I'm just giving it a name, which is my package. Okay, and I also need to define the version. Okay, so 0.0.1. Okay, I'm giving version as this. Okay, okay, then you have the second, after metadata you have the second parameter, which is options. Okay, now what is options? Options is where you define what are your packages. Okay, so here you have to define all the subdirectories which are present in your code. Okay, so I have only one subdirectory, which is subdirectory is what? Only subdirectory is the folders where you have the code is stored. Okay, so I have only one subdirectory whose name is my package. Okay, so I will give my package as my packages. Okay, so it's basically like a subdirectory. Okay, all the subdirectories inside your code, inside your top level directory, will come inside this package parameter. Okay, okay, now you can also define uh, some additional properties, which is basically install requires. Okay, so inside options only you can define install requires. So inside install requires, what you will do, you will give the name of all the you will give the name of all the libraries which are not in which are included in your code. Okay, so let's say I'm using requests, so I'll give the request library. So this install requires parameter will install all these dependencies. Okay, one from your WHL file. Okay, so I will define all the parameters I'll define all the external libraries which I need. Let's say Numpy, then let's say I'm using pandas. So I'll define all these. Okay, and the list goes on. But as of now I'm not using it, so I don't need to. I mean, I'm not using any external libraries in my code, right? So I don't need this. But just to show you that how you will incorporate the external libraries, I just showed you. Okay, so you can define install requires inside that. Okay, so as of now we don't need that, so we will skip that. And so options is done. Now I will give the entry points. Okay, so options dot entry uh, points. So now what is this parameter? This parameter is basically responsible to give the name on the command line. Okay, so this gives you the functionality to execute any function on command line. Okay, so in my code I have defined these two functions, right, which is my function and another function. So what this option entry point thing will do, uh, yeah, inside the entry point, let's first define it and then we will understand it. So we will give it like console scripts equals, and then inside that you can give my application equals my package. So this is the name. We'll understand it. First just complete the two entry points. My package dot my module. Okay, my module, and then a colon, my underscore function. Okay, this is my first entry point. The second entry point would be the name of the entry point, which is another function. equals my package dot my module. Okay, my package dot my module, and then the name of the function, which is another function. Okay, so what I have done over here is I have defined so I have my package, which is folder my package. Inside that I have the file my module. From that I'm taking my function package, my function. From that I'm taking this function. Okay, and this I'm defining it as a console script entry point. So if I just run my application after I have installed the .wheel file, if I just give my application on the command line, it will run this my function. Okay, if I just type another hyphen function on the command line in my virtual environment, it will execute another function. Okay, so this is how you can execute any function inside your code as a command line, uh, interface. Okay, as a CLI command. Okay, so we will see it. Once we see it, it will become more clear. So let's save this file. So this is my setup.cfg file, right? So save as. I'll again go to the same folder, which is my repo. Inside that I have this, where I have this setup.py file, and I'll name it as setup.cfg. Okay, and I'll save it. So setup.cfg file is done. Let's close it. Now let's come back to our requirement. Okay, so now setup.py is done, setup.cfg is also done, and this functionality is also done. Now we just need my pyproject.toml file, right? So let's create that. I'll open Notepad again, and as we discussed before, this toml file is used and it contains build system requirement related things. Okay, so if you want to read more on that, you can just Google setup tools, about setup tools, and you will be able to understand it. So build systems. So this is my pyproject.toml. Okay, now I will give build backend is equals, I have build backend parameter as setup tools dot build underscore meta. Okay, so this is my backend, and this requires is a list. Inside that I'll give setup tools, comma, I also need wheel. Okay, and that's it. That's the content of that's the basic content of a toml file. Okay, it's a very basic starter code. I mean, you can read about the contents of, you can always customize your setup.cfg, you can always customize your setup.py, you can always customize this toml file for any advanced functionalities. Okay, so this is a very basic thing for you. I am just showing you how to get started and how to what all parameters and things you need and what all you could define. Okay, so again I'll save it as py project. You can give it any name. I'm just giving py project. Okay, py project.toml, and again I'm saving it inside the root directory, which is my repo, right, where my setup and setup.cfg file lives. Okay, so py project.toml, and I save it. Okay, so this is also done. Let's close it. Okay, so now let's check the content. I have the top level directory. Inside that I have my package. Inside that I have code, and inside the top level directory I have pyproject.toml, setup.cfg, setup file, right? I have all the requirements. Okay, now we will test. So what we need to do is we need that .whl file, right, from here. So what we will do is we'll go to command prompt. We will go inside the top level directory, which is my repo. So cd my repo, I'll just zoom in a bit. Cd my repo. After cd my repo, you have to give py-m build. So you can also give if Python is added to path variables, then you don't need to give -m. Otherwise, you can just give py build, Python build. But here my Python is not added to the path variable, so I'm giving py-m build. Okay, let's give this command inside the top level directory, which is my repo. So I have give this command. So it is building. Okay, so I might have done an error. Okay, so okay, I have done it is giving a warning, right? It is giving found build systems in pyproject.toml. Did you mean build system? So it was build system. I have given build systems. So I need to correct that. So I will go to my top directory. Okay. So this is the output. These two folders, dist and my package.egg-info was not there, right? So these are the output of the build command. So let's delete this for as of now because it might create some problem. Let's create the CFG file again. Or sorry, this pyproject.toml file I need to create again. So I'm deleting it because I did a spelling mistake inside it. So it should be build hyphen system. Okay, build hyphen system. Then build build hyphen backend equals it's a string setup tools dot build. Okay, I'll zoom in a bit. Setup tools dot build underscore meta. Okay, this is my build backend. Then requires, so it's with a S. Let me just check it. Yeah, it's with S. It's a list. First one is set up tools. Okay, and the second one is again a string wheel. Okay, so this looks good. I have corrected the build system spelling. Build backend, build hyphen backend, setup tools dot build meta, require setup tools and build. Okay, so let's save it once again. Save as, and I save it as pyproject.toml. Okay, in the root directory. So yeah, this looks good. And now I have pyproject.toml. So let's go to this again. Okay, I'm inside my root directory. Let's give py-m build again. Yeah. Okay, so it is now the warning is suppressed. You can see it is creating the process of build for my project structure. Okay. It is also, so if you see this file, yeah, so all the requirements and everything, it is creating that. I mean, it's a process in which it kind of creates that additional Python package requirements and all that stuff. Okay, so if you see, I have the process is finished and it is saying successfully built my package. This is the version tar.gz and my package. So this is my wheel file. Okay, .whl. If you see successfully built my package, this file and my package .whl. Now where is this file located? If I go to the root folder, there are two additional folders. If you see after this py-m build command, these two are my additional folders which got created right after I gave the build command. Now if I open the dist folder, I have these two files, tar.gz and my package version py3 dot whl. So I need this whl file. Okay, as we saw in the Python extensions, you have whl files, right, which you will be compiling using pip. Okay. Okay, so let's install this whl file which we have got. uh, yeah, so let's install this whl file and let's test whether our uh, code is working in a virtual environment. Okay, so I'll just google virtual environment, how to create virtual environments. So for creating virtual environment, you need to have this package which is virtual environment in your uh, pip install virtual environment. Yeah, so you need to give this command pip install virtual env. Okay, to work to create virtual environments. Okay. Okay, so I have this virtual environment already installed. So I'll just create a virtual environment. Now, why I'm creating a virtual environment? Just to test, uh, because inside virtual environment, I will not have all these dependencies. I'll not have this package installed, right? So let's test whether this is virtual environment will mimic basically some other systems. Okay, so let me just test it. So first I'll create a virtual environment, and the command is, yeah, so the command is virtual env, which is the module, and then you give the name my env. So this is the name of the virtual environment, my env. So enter that. Okay, so it is saying created virtual environment. Now we need to activate the virtual environment. So the command is my env, the name of the virtual environment, slash scripts slash activate. So I need to activate uh, so it is saying my env is not recognized as an internal batch or external. Okay. Okay, it's my env. Okay, my env slash scripts and then slash activate. Okay, so now it got activated. I gave the wrong slash. It should be the other direction. Okay, so now how do you know that it is activated? Next to my command, where the location is shown, it is printing the virtual environment name, right? This is my virtual environment. So now I am inside my virtual environment. Okay, so now let's install that wheel package. So pip install. Now what I need that wheel file location, which is so this is my wheel file. Let's go to properties. So I'll just copy the location and I'll paste it here. And then after the location, I need the name of the wheel file, right? So I gave this command inside the virtual environment. I gave this command py-m pip install location of the file, which was desktop my repo dist. Inside dist folder I have this wheel file, right, followed by the name of the file. So let's install it. Let's press enter. And it says installed collected package, my package successfully installed my package, and it's printing the version. Okay, now I can test my functions. Okay, so whatever my functions name, so what were my entry points? If you can remember the entry points, it was uh, another function and um, my function, right? So we defined some entry points in the config file, right? So it was my application and another application. My application was to execute this my func, and another application was to execute this another func. Okay, so those were the entry points. So now if inside this, if I just give another function, I'm not giving Python run this script whatever. Okay, I'm just giving another function, and it prints hello from another function, which is the content of another function. I gave the command another function and it printed the content of another function. Why? Because inside my virtual environment I have installed uh, whatever was my code as a package. Okay, so my package got installed, and when I gave another package, another function, it is printing hello from another function. Let's execute the second function. So for my function, for executing my underscore function, the entry point was my application, right? If it was defined in the config file, so my application, and it prints hello from my function, first name Utkarsh, last name XYZ. Again it is printing. So this is the content of my function, right? First it prints hello from my function. It printed hello from my function. I'll zoom in a bit. Yeah, so it printed hello from my function, and then in a while loop it will just call this call function. Okay, and what is inside call function? It contains a dictionary, and it is just printing that dictionary, and it sleeps for 5 seconds in the while loop. So it is executing the same code, right? First it executed hello from my function, then it is printing the dictionary because call function is getting executed after every 5 seconds. Okay, okay, if I stop this program, I run again my application, and there you see it is printing, it is executing the code. Okay, after every 5 seconds it is printing that dictionary because I've called the call function inside the my function. Okay, and the entry point is my application. So I'm just giving the entry point name. I'm not giving Python py, or I'm not giving the Python command, right? There's no .py extension, there's no file involved. Using just the entry points, I'm just able to execute the functions. Okay, whichever function I bind to this entry point will get executed. Okay, so this is a better way in which you can distribute your Python code, right, to other people. So what is the method? You just need the access to this. You just need to create a project structure, build everything. Then you have to create this. You need access to this .whl file. Okay, and then you can tell the developers to pip install your WHL file in a virtual environment, and then they can start with the coding. Okay, they can access your code. So that is how you distribute the code. So even if I do py, I execute the Python application. Okay, now can I import my package? Yes, I can, because it's now installed on my system or in my virtual environment. So if you see it was the name of my package was my package, right? It was my package. So like you import numpy, pandas and stuff like that, now you can import now if people have installed using WHL file, which you will distribute, right? So if people install using that, they can also import functions from your code. Okay, so I can import my function from my package. Okay, so I can say from my package dot my module dot my module. So this was my file name, right? My module.py, and it was inside the folder my package. So from my package dot my module, import my function. What is the function name? My underscore function. So I can also import it. Import my underscore function, and it executes. Now from I can execute my function. I'll just call my function, and it is printing. Again, now I can execute anyone who has the access to my wheel file, and if he has uh, installed my package, then he can have access to the code which I have written. Okay, he can so these things you can include in your documentation, right? For whatever, for let's say this is printing the name, right? So let's say your library name is print my name. So in the documentation of print my name, every library has a documentation, right? So inside the documentation, you can give the usage. So first import my package, then my package has a file, my module, and this has a function which is my function. So this becomes documentation, right? And you just execute the my function, and you can basically it prints your name, right? Okay, so I hope this session was useful to you in some way or the other. We saw how can you create project structure, and how can you create .whl files which you can distribute, and as a from let's say you can give a download link from a website from where users can download your WHL file, and they can build using they can install that WHL file in their system using pip command. And yes, and once they do that, they have access to all the codes, which all the functions that are inside your that you have defined inside your package, and how to use them, that becomes the part of documentation. Okay, so that is how so if I give you an example of what I mean, let's say I give pip install request, pip install. Okay, let's take term color. Okay, so this is the file, right? Now if I go you give pip install term color directly, right? So if you go to download files, you have these uh, tar.gz, and we used .whl file, right? Here they have used the tar.gz, which is this one. Okay, so they have used this one. You can also use the tar.gz file. So this is the source distribution. Okay, so they just give the link to download these files. You can download them, and then uh, so these are, so let's say this for numpy, this is the .whl file. So for Win32, for your system 32 architecture or whatever, uh, you can download based on the Python version, for Python 3.9, for 3.8, 64 AMD Win 64 AMD architecture, 32, all these different according to Python versions. These are the wheel files. Okay, so you can download them. So let's say I choose when my Python version is 3.8, and I choose this file. Okay, so this is a downloadable link, and it starts downloading, right? So after this download is done, I can give pip install. I can install this file, and I can use whatever functions are inside numpy library, right? Same way, we have created a library which contains this code and these functions, and how you can create a .whl file, I've already shown you. Once you create a .whl file, just distribute it in form of links hosted on a website, and then anyone can download the WHL file and using the once they refer to the documentation about how to use those functions, they can start coding, right? And they can get access to your code. So this is how you distribute. This is a way. I mean, there are multiple ways to distribute a Python code, but this is just one of them. So you can use. It's very simple. You create a project structure and then you create WHL file, distribute it, and then everyone can have access to your code. So this is one of the ways. I hope you'll be able to create some fantastic libraries and codes which you want to distribute to other developers and into your organization, or you want to create a cool project, you want to distribute it, and you want everyone from the world to use it. You can just host your WHL file, right? The process for that was this. So I hope you'll create something cool out of it. And if you create something cool out of it, just don't forget to post it as a comment, or post a link uh, of your project in the comments. Okay, whatever you create, just let me know in the comments. And yeah, so that's pretty much it for today's session. Okay, and I'll see you in the next one. uh, until then, take care and stay safe. That's pretty much for it. Yeah, bye. Don't forget to share this video also, because it helps us and it keeps us motivated in the long run. So share this video with your friends, with your colleagues, and make just anyone who is trying to learn Python. So I'm hopeful that it will be very useful for them in some way or the other. So just, yeah, make sure that you like it, you subscribe to our channel, and you share this video. Okay, I'll see you next time very soon. Take care.